Here are the answers for the section 14-2 homework. Number 1, write polynomial p in the form so that there's a binomial in parentheses, then a multiply, and then the quotient that you get. This is going to be a polynomial whose degree is 1 less than the degree of the original polynomial. And then if there's a remainder, that's going to go on the end. So to do this, we're going to divide our r value into this polynomial using synthetic substitution. So write down the coefficients. 3, -2, 2, and 1. That's this number, this, and this. Then make the bracket. Take the value of r, which in this case is 2, and write it out here on the side. Now run through the process. Bring the first number down, multiply this times this, which makes 6, and write it down under the next number. Then add these together, that makes 4. Multiply the 4 times the 2, which is 8, and write it under the next number. Now add these, which is 10. Multiply, and then add. This number on the end is the remainder. This is the P of R. These three things right here are going to be the coefficients of Q of X. So when we write our answer, we're going to follow this form right here. So our answer is a parenthesis, and then x minus r value for r, which is 2, close the parentheses. Then multiply by polynomial Q of X, which we can find from these coefficients. It's 3x squared plus 4x plus 10. Then there's a plus sign where we're going to add on a remainder. So plus the remainder of 21. Here is the answer. Next one, let's follow that same pattern. Write down the coefficients from polynomial p. So the 1 from the x cubed, the 4 from the x squared, the 3 from the x, and the constant of 2. Divide in the value of r, which is -3. Now run through the synthetic substitution process. 1, -3, 1, -3, 0, 0, 2. Use these three numbers for Q of X. Use that number for the remainder, which is P of R. So our answer is going to be x plus 3 times, now Q of X, 1x squared plus 1x plus 0. I'm not going to write the plus 0. Plus the remainder of 2. This part right here is the x minus r. It's just our r is a negative number. So it's x subtract -3. That's why I wrote it in as a plus sign. This right here is 1x squared plus 1x plus 0. The 1, 1, and 0 come from these three numbers in the synthetic substitution. Next one, let's do it the same way. So we have 1, -3, -1, -11, -4. Divide in the value of r, which is a 3. Bring the 1 down and multiply. Now add these. Now multiply. Add these. Now multiply. Add these. Now multiply. And add these. The answer is x minus the r value, which is 3, times q. Well, we got to figure out q. This number's the remainder. This number's the constant. This goes with x. This goes with x squared. This goes with x cubed. So it's 1x cubed plus 0x squared. I'm not going to write that. Minus 1x minus 14. And on the end, plus the -46. If you like, you could write that as minus 46. So here is the answer. Number 7, find the quotient and the remainder. We have this 4-term polynomial and we're dividing by x plus 3. In an earlier chapter, we would do that using long division. This time we're going to do synthetic division, which is the same thing as synthetic substitution. Write down the coefficients. 3, 11, 11, 15. Now divide in the value of r. But what is the value of r? Remember that when you look at this over here, the value of r comes after a minus sign, but there is no number after the minus sign. You need to think of this as if it was x minus negative 3, because now we can see what r is. R is negative 3. It's negative 3 that we're substituting in when this is x plus 3. Another way to think of it is, what's the value of x that makes that a 0? What's the 0? It's negative 3. Now let's run through the pattern. 3, negative 9, 2, negative 6, 5, negative 15, and 0. This number on the end is the remainder. These 3 make the quotient. So let's write our answer. The quotient is 3x squared plus 2x plus 5. The remainder is 0. Number 9, let's do this the same way. So we have 3, negative 6, 0x squared, then 3, then 4. And we're dividing in 2i. Let's run through the process. 3, 6i. When you add this together, it's negative 6 plus 6i. Now multiply this by the 2i using distributive. Negative 6 times 2i is negative 12i, and 6i times 2i is 12i squared, but 12i squared is negative 12. Now add these together. I'm going to move the 3 and the 4 a little bit further over, starting to get crowded. Let's multiply our negative 12i minus 12 by the 2i that's out front. Negative 12i times 2i is negative 24i squared. That makes 24. Negative 12 times 2i is negative 24i. Now add these together. It's 27 minus 24i. Now multiply that to the 2i. 27 times 2i is 54i. Negative 24i times 2i is negative 48i squared, and that makes positive 48. Let's add this to the 4. So we have 54i plus 52. This last piece is called the remainder. This piece will get us the quotient. So let's get our quotient. This is the constant. This goes with x. This goes with x squared. This goes with x cubed. So it's 3x cubed. Then it's negative 6 plus 6i x squared. Then it's negative 12i minus 12 times x. And then it's 27 minus 24i. That's the quotient. Let me call that just Q to keep track. Now let's do our remainder. It's the 54i plus 52. Next, number 11. Show that this binomial is a factor of this polynomial. For this to be a factor, it has to divide in there evenly. When you divide it in, you have to get a remainder of 0. Let's use synthetic division. 2, negative 11, 12, and 9. Now, what number are we dividing in? What's the value of r? It's 3. Run through the process. 2, 6, negative 5, negative 15, negative 3, negative 9, and the remainder is 0. Because the remainder is 0, x minus 3 divides evenly into that, so it is a factor. Number 13, is x plus 1 a factor of this? Well, let's find out. 6, negative 7, negative 7, and 6. And what we're dividing in is negative 1. Again, we talked about that earlier. This is supposed to go x minus r. So it's like it's x minus negative 1. Okay, bring down the 6, then multiply. Add them, and multiply. Add them, and multiply, and add them. And the remainder is 0 again. So this is a factor. Number 15. This time we have an equation. You see how it's an equation? It says equals 0. It's got a left side and a right side. What numbers could you plug in for x so that the left side makes 0? We wonder, is 5 one of those solutions? Is 5 a root? Well, let's check that it is. Not by directly substituting it in. That's what we did earlier this year. Instead, let's check with synthetic substitution. So we have 1 from the x to the 4th, then negative 16, then 86, then negative 176, and then 105. And the number that we want to substitute and see if it works is 5. So let's run through the process. 1, 5, negative 11, negative 55. This is 31. 31 times 5 is 155. This makes negative 21. Negative 21 times 5 is negative 105. And when you add these, it makes a remainder of 0. So because there's a remainder of 0, the 5 goes in evenly. Yes, this is a root. When you substitute 5 in for the x, it does make 0 because we got 0. Now number 17, let's substitute in the letter I and see what happens. So we have 1, negative 3, 1, and negative 3. And we're going to put in an I. So bring down the 1. 1 times I is I. Add these together. That's negative 3 plus I. Negative 3 times I is negative 3I. And I times I is I squared, but I squared is negative 1. When you add these together, it's negative 3I. Negative 3I times I is negative 3I squared. That makes positive 3. And when you add these, it makes a 0. So yes, I is a root of the equation. Number 19, find this part right here. Well, this kind of fits the pattern we were using earlier. Let's use synthetic substitution again. We have 2, negative 7, negative 21, and 54. What's the value of r? It's a 2. So put in a 2. Bring down the 2. 2 times 2 is 4. This adds up to negative 3. Those multiply to negative 6. These add up to negative 27. And those multiply to negative 54. And these add up to 0. Remember, this thing on the end is the remainder. And it was this part that was our quotient. So it asks us, what is the quotient? I guess it's 2x squared minus 3x minus 27. Okay, next one, number 21. Write down the coefficients, 2, negative 3, negative 4, and 1. And divide in the correct value for r. It's negative 1. Now run through the process. 2, negative 5, 5, 1, negative 1, 0. This piece is the quotient. So the answer for Q is 2x squared minus 5x plus 1.